Hey everyone, welcome back to the channel. If you've been following along, you know I have covered PX4 software in the loop back in 2019 and again in 2022. Since everything is changing in this field a lot, today it's time for an updated video for 2025, featuring the latest instructions with WSL2 and the PX4 development environment. And of course with the new simulators now in the store such as Gazebo Garden, Explain and so on. Whether you're a seasoned developer or just getting started with drone simulation and never experienced a real-world drone operation, this video is packed with everything you need to get them running quickly in 2025. So let's jump right in. So why should you consider using SITL or software in the loop? Or what is software in the loop in the first place? Let me break it down for you. Software in the loop, or SITL, or some people say SIL, is an incredible tool that allows you to fly a drone visually without the risk of crashing your hardware. It's perfect for testing missions and exploring different scenarios in a safe, controlled environment. Plus, if you're experimenting with custom code using mavsim, mavsdk, or any other tools, or even developing a new airframe, SITL lets you see the results in real time. This way, you can test your missions, operations in various scenarios and be fully prepared before taking your drones to the real skies. You can run SITL on Linux, Windows, macOS, or even in a Docker container. A few years ago, as I mentioned in my 2019 video, my advice was to go straight for Linux and not bother yourself with Windows toolchains and other stuff that you might interfere. But with the latest WSL upgrades, you can do everything you need right within your Windows. In this video, I'll walk you through all the steps for setting up WSL, the PX4 development environment, jmavsim, QGroundControl, extracting your log and review it using PX4 log review, Gazebo Garden, Gazebo Classic, and some other community simulators such as Explain. You can still achieve the same result on Linux and macOS, which are pretty straightforward. Maybe in the future I'll create video about those setups as well. Okay, let's set up our PX4 development environment in WSL. Just as before, I want to emphasize that everything you need for this project is already available in this documentation page. So by the time you're watching this video, maybe some steps have been changed, so always check the latest documentation in this page. Let's start with the installation step. As you can see, it's recommended to use Windows 11 or the latest updates from Windows 10. And you need to enable virtualization from your BIOS or your CPU and motherboard configuration. Usually by default it's on nowadays. But if it wasn't, go ahead and search for your motherboard and CPU brand or your laptop brand in Google and search how you can enable virtualization for that specific brand. That's just a relatively easier step, and usually, as I said, most of the time it's already available and already turned on. Next step is we need to turn on some features of Windows. What are these features? Some of them such as Windows subsystem and Linux. You can search for turn Windows features on and off in your start menu and you will find these options already in this list. There are some options such as Windows subsystem for Linux, Hyper-V or Windows virtualization. But in the latest update of WSL, you don't need to enable these features manually. It would enable it by itself. So for the sake of demonstration, I'm not going to enable any of this and I'm going to leave this as it is right now. And what happens is that when we install WSL, it would automatically enable all the features that it wants. So let's go to the next step. We need to run cmd command line or PowerShell, whichever you feel better. But make sure you run it as administrator. We can type wsl -install and it will install the latest version for you. Right now it's 1.22, but we can specify exactly the version that we want. Here we are in PowerShell, and as you can see, we have opened with administrative privileges, and I'm going to type wsl -install -d to specify exactly the operating system and version that I want, which is Ubuntu 22 LTS. And now all I have to do is to wait a few seconds. You can see that it's enabling the features that we were just talking about. It's enabling virtual machine platform, and maybe Hyper-V or Windows subsystem for Linux. And all we have to do is just have a coffee break and wait for a few moments. Okay, great. If you see this message, it means your Windows is ready to run the WSL. All you need to do is just reboot your system so all the features would start working. I just rebooted the system and here we are. The PowerShell or the terminal would automatically run on a startup because it already knows that we are in the middle of installing Ubuntu. If it didn't automatically open, there was something wrong. Go ahead and install WSL again, and just like the last steps that we have. Here we are. Now it asks me for a new name for my user in Linux. I'm gonna type Alireza and just a sample password. And here we are. Believe it or not, we are inside an Ubuntu. In our Windows, we can type who am I to see that yes, it's the user that we have just created in Linux. And we can double check the parent directory. Let's exit and continue with the next step. Imagine you want another version or some other things, some other operating system. You can still do that. With WSL, you can have several systems. Just go ahead and open a new PowerShell. There are lots of ways you can open your WSL or install a new WSL. For example, you can type WSL-list to get the list of already installed Linux system. Right now, we have only installed Ubuntu 22, and which is the default one. You can type WSL-L-O to get the list of all available subsystem for Linux that you can install on your Windows. For example, you can type WSL-install-D and Kali Linux. And then in just a few moments, you would have another subsystem, another Linux inside your Windows, totally separate, and which it would be Kali Linux. You can open or run any of the Linux instances that you want using the WSL command. You can type WSL-D Ubuntu 22 and then your Ubuntu would run up. And if you only have one WSL, and which is the case right now, you can just type WSL and it would work the same. If you want to install another Linux instances, I would recommend you using Microsoft Store from now on, because it's gives you better support. It gives you some GUI and user interface. You can see different versions, different descriptions, different version information. For example, Debian, Arch Linux, or different versions of Ubuntu, Kali, or even some preview versions from Ubuntu. You can just go ahead and type the name, search for it, and install it without any need to use command line. But let's be honest, if we are gonna use Linux, we love command line, so anyway, it doesn't matter. The benefit of using Microsoft Store is that it will check for the updates automatically for you. Let's go ahead and continue our WSL operation. We can type WSL-L-V to make sure if we are using WSL version 2 or not. If for any reason you are not using version 2, make sure you type WSL-set-version Ubuntu 22 and then space 2. You can still use WSL 1 if you want with PX4, but if you want to have the visual interface such as Gazebo, Simulator, and other systems, it's better to use WSL 2. Okay, now let's run up our Linux. Because we only have one instance here, all we need to do is just type WSL, and here we are inside our WSL. But remember, there's one more very important thing. We are not in the home directory. Always make sure you type cd tilde to go to your home directory of your Linux. And from now on, we are a Linux user. Just go ahead and do some routine operations in Linux. Let's update our repository by typing sudo apt-get to get all our repository updates. Now you can also do sudo apt-upgrade to upgrade your packages. Now that we have our Linux up and running, we can continue our steps and instructions for the PX4 code base. So we can proceed to the next step, which is cloning the PX4 repository. We have done all these steps. Just again, I recommend you to read all these steps. Okay, now we need to clone the PX4 repository. using the git command. Just copy and paste this git clone to get the latest code base of PX4. If you don't have git installed, you can just install it using sudo apt install git. Depends on your internet connection. It might take a few seconds or maybe a few moments. It's gonna download a couple of 100 MB. Always make sure it won't break. Sometimes because it's a huge code base, sometimes we face with EOF, means unexpected end of files. Make sure you're not getting any of those errors and the code base would be received successfully. Okay, done. And now if we type ls, we see the new PX4 autopilot directory have been created in our home directory. Now we need to use this installation script, which makes the work much easier for us. It would install anything that we need for just general purpose use with just one command. All you need to do is to copy and paste this and run this shell script, and it would take maybe about 2 or 3 minutes or up to 5 or 6 minutes or something. So you're gonna need to have a short break. But again, make sure there's no errors in between. If you have some internet connection issues or some maybe limitation in your network, you might face with some errors or some packages would be ignored and not installed, and then later on when we want to build the code base, you would get errors. So the key point is to make sure there would be no errors in this process and all the package would be installed successfully. Okay, after about 5 minutes we are ready, and as the documentation mentioned, it's recommended to restart your WSL instance, not your system, just your WSL. So just type exit and then you can type WSL -shutdown to shut down the Windows subsystem for Linux module, and we can run the subsystem for Linux again by just typing WSL. And here we are. In theory, we are now ready to build our code base. Just let's test if it's success or not. We can cd to our home directory again as always, and then cd to the PX4 autopilot. For the sake of demonstration, we're gonna type make PX4 software in the loop without any simulation or anything. We just want to make sure our code base is complete and it works. If hopefully after a few minutes I won't see any errors on the screen, it means the code base is healthy and it means we can go on for the simulation. I tried to simulate all these steps live in real time in a fresh installed Windows 11 to see if any errors arise, but nothing so far I saw. But it might not be the case for you. If you find any errors, although there is a small chance you would find errors because the execution and launch files have been simplified a lot, but again, still, if you find some errors, make sure you Google the exact word of an error message. Definitely there were some other people before you that have faced with these errors, so you would definitely find the solution. But there are some general troubleshoot commands that I will show you on the screen. If you find errors, go ahead and type git stash, then git pull, and then git submodule init, then git submodule update -- recursive, and then make this clean and make clean and make the code again from scratch. This way you would make sure there's no missing packages or missing dependency or something happens during the updating the packages. Okay, here we are. We didn't see any errors, and I hope you see the same message as I can see right now. If you see this, congratulations, you're ready to continue. Next step, if you're gonna do some code development, it's recommended to install Visual Studio Code and connect it to your WSL. It's very simple steps, just copy and paste these commands. But I think it's more for expert people, so I'm not gonna discuss that here. I already discussed that in my last video of WSL with PX4. Then you need to install the QGroundControl. You can install it on Linux or Windows. I recommend using Windows, and we will cover that in the next steps. We have different options for our simulation environment, such as Gazebo, jmavsim, and so on. One of the easiest one to use, and I like it so much for just testing my code so quickly, is using jmavsim. jmavsim is kinda old and very basic, but it serves the purpose for testing the code. It's very good interface for just testing the code. So let's start with jmavsim, and we're gonna use the jmavsim documentation from PX4. For the most basic setup and demo, all we need to do is just type make PX4 SITL and jmavsim. But there's a problem here, and maybe by the time you're watching this video, this problem have been solved. But in WSL, two packages have been maybe missed from installing using the installation script. So you need to install it manually. Go ahead and type sudo apt-install ant, type your sudo password. After ants have been installed, the next thing is that you need to install the JDK or Java or JRE, Java Runtime Environment. You can use the latest version. Right now it's 16, but I found that version 11 works fine with jmavsim, so I'm gonna type sudo apt install openjdk-11-jre, and here it is, JRE version 11 is installed. If you have different versions of JDK, you should configure it and set which one to use by default by typing sudo update alternatives --config java, and as you can see, I have version 8 and version 11. So I'm gonna type 0 to set it to auto mode. So that's it. All I had to do is to install the Java runtime environment and ant, which maybe have been missed from the installation script. That's it. Maybe by the time you're watching this video, this problem have been solved and you don't need to type these commands manually. Let's do it again. I type make this clean and make clean and run the make PX4 SITL jmavsim again. And this time, as you can see, we see no errors and jmavsim is building, and also PX4 codebase is building. And in a few moments, jmavsim would automatically run. So as you can see, the jmavsim is up and we see a basic quadcopter and a virtual environment. So what's next? Next is that now you have your software in the loop environment. You can do whatever you want. You can just play with your quad with just commands such as commander takeoff, and your quadcopter will automatically take off and go to the 2.5 meters altitude. And then you can just type command land or change flight mode or connect the joystick or use QGC or use your scripts in Map SDK or Map ROS or any other Mavlink API. That's the tool you need for your development. But let's go ahead and use QGC. As I told you, we need QGC for our operation, both for the educational purpose and our test cases. You can install, as I told you, you can install QGC on Linux. Although it's possible, I'm not a fan of that. I recommend having a QGround on Windows. It's very easy. Go ahead and download the executable just like any other application, install it, and when you open it, there's only one step you need to do. You need to tell the QGC to connect to Mavlink stream from the WSL. All you need to do is to get the IP of your WSL instance. So enter your WSL again and just simply type IP ADDR, or maybe you can also use ifconfig. This is the IP of your WSL instance on the WSL subnet. So you need to tell the QGC to get the Mavlink stream from this source. We go to the comlinks and add a new comlink, call it WSL. You can also enable automatically connect. The port should be 18570 instead of the default 14550. And you need to add the server address here, which is the IP of the WSL instance. And done. All you need to do is to select the comlinks and connect.
Hold flight mode.
Here we are. Now we have the drone on QGC. If you want more advanced control of your Mavlink stream, make sure you check my documentation and a tutorial on Mavlink Anywhere to use Mavlink Router to route your Mavlink streams to any source that you want or any destination that you want. It's another video, and for more expert users gonna use different use case for Mavlink stream with Mav SDK or maybe Mavros or several ground stations. But if you need that, go ahead and watch my tutorial on Mavlink Anywhere and Mavlink Router. Here we can do all the commands and test all the QGC operations, such as sending the drone to a mission or sending to takeoff command and land command, and you can test and try different sort of options and menus and windows of the QGC. One of my favorite use cases of software in the loop is use the logs. We can use the log as it was a real flight, which is a very good tool for students and beginners and even advanced developers that have want to test some code on real drones. So they can use the logs from the software in the loop just as it was a real flight. For that case, just go to the log download window and download the logs that you want. There's also another way. Instead of using QGC, you can directly use the Linux file structure from your Explorer on Windows. Go to the home and your user directory, then PX4 Autopilot, then build, then software in the loop, root fs. And here you can see all the files that would in a normal real world operation would be available on the SD card of your PX4 or Pixar board. Open the log and you would find the same ULG or ULog files here. You can use this ULogs in different tools such as MATLAB and Simulink UAV Toolbox or several other analyze software, but the most easiest and just free option that you have online is using a PX4 review. Just go ahead and search review PX4 in Google and you'll find this review.px4.io. All you have to do is to upload your ULog file here, give it a name, maybe Hello World WSL or Hello World SITL. Put your email so the link of the log would be sent to you and you can share it with other people or share with your team. And just upload the ULog file here. After a few moments, you will find this very interesting and informative page. All sorts of information from the map location, from some overall statistics of the version and hardware and software, to all the details of your system, any logs or any errors, attitude rate, set points, motor output, some PSTs of your vibration, just anything. I think there are lots of PhD theses that can be implemented using the information here. So it's very informative. You can use OpenPID analysis or use the 3D view, or you can even browse and see other people's logs. It's just a whole set of laboratory here. Now that we have successfully used jmavsim and run our first simulation, let's put one step ahead and use Gazebo simulator, which is much more advanced, and you have flexibility to create your custom drones and lots of already available commands here. The easiest one is the Gazebo with X500 drone. All you have to do is just type make PX4 software in the loop, this time GZ_X500. And then you would have this GUI. For those of you that you have old history with PX4 and Gazebo Classic, you would find this window very modern style, but it's basically the same thing. You have a quadcopter here, just like our last test case. You can connect your QGC, but I think the most important thing is to change it to the dark mode, although I would recommend the developers to make the environment also dark. I am the fan of the dark theme, but you can add some modules easily with just one click here. For example, you can add a cone here and use it in your image processing or object collision avoidance or path optimization. You can add some maybe trains or some trees, mountains, lights, and so on. Sky is limited. You can do many things with Gazebo. Gazebo is a very advanced simulator. And we have also connected our QGC just like before. Now we can let our drone to take off. Maybe this time send it to autonomous mission. We send it to take off, just create a simple square or maybe a triangle and return to launch. We send our drone to the mission
flight mode.
and you can see in the simulation it's armed, take off.
Return flight mode.
You can do a lots of maybe innovative project with Gazebo. Gazebo has lots of packages and visual graphic interface. It's very good integration with ROS. So if you're gonna continue your career in robotics, make sure you check all the details of Gazebo. Although the new Gazebo is very cool, many of us from the last generation working with robotics have lots of good memories with Gazebo Classic and still love it. Although it's Gazebo Classic life cycle would be ended in the first of 2025, which is maybe a few days from now, but still, especially many ROS developers, ROS 1, which is also going to the end of its life, still love Gazebo Classic. So let's go ahead and use Gazebo Classic as well. In the Ubuntu 22, Gazebo Classic won't be installed automatically. So if you want to use Gazebo Classic, you need to remove the new Gazebo Garden. So go ahead and copy this command inside your WSL and it will remove the new Gazebo and install the Gazebo Classic and all its dependencies for you. Remember, you can't use both of them at the same time on the same instance. You need to either use WSL with Gazebo Garden, which is the new Gazebo, or the old Gazebo Classic. If you need them both, go ahead and create two WSL, maybe two WSL Ubuntu 22, or maybe just use Ubuntu 20 for the Gazebo Classic and Ubuntu 22 with the new Gazebo. So, and if you are newcomers to this world, you don't need to use Gazebo Classic, although I myself like Gazebo Classic more, maybe because I have better connection and I understand it better, but the new Gazebo is much more powerful. So if you are new and you haven't used Gazebo Classic, go ahead and continue using Gazebo. Maybe some people need Gazebo Classic because of their ROS and old ROS dependencies. This part of the video is only for those kind of people. Okay, here we are. Hopefully we can just imagine it's just a few years ago and it's maybe 2022 and we just type make PX4 software in the loop Gazebo for the most basic demo of the Gazebo, and in a few moments you would see the good old lovely Gazebo Classic again. Okay, here we are. This is our good old Gazebo Classic and we have our Iris drone by default. And everything is the same story as jmavsim or Gazebo Garden. You can connect your QGC or use command line to send command to the drone. Let's just do the same thing we did with Gazebo Garden.
Hold
Connect
flight
our
mode.
QGC and send it to an autonomous mission.
Mission flight mode. Armed. Return flight mode.
Okay, so far we discussed Gazebo Garden, Gazebo Classic, and jmavsim, which are officially supported simulator for PX4. But there are a bunch of community supported simulators such as Flight Gear, JSVSim, AirSim. And the one specifically I want to introduce you is PX4 Explain, which is still in very early beta stages and not recommended for small drones. It's only recommended for big drones. So if you're familiar with the Explain, you know what possibilities you have if you combine PX4 and Explain. There are already some options here for you for some air taxis and big airplanes, and there's good documentation here. You can follow and create your own customized drone, customized airframe. For example, in this page, in this demo, you can see on top left it's a EHang 184, on top right is the fixed wing for the Bayraktar TB2, the bottom left is Alia 250 air taxi, and bottom right is Cessna 172 fixed wing. You can build any type of airframe that you like with this PX4 X-plane and run it on your X-plane and connect it to your PX4 software in the loop. But as I told you, it's more of an expert option. If you are a beginner, you don't need to do that. There are very good documentation here, but there are some prerequisites. You should have a very powerful computer, be able to run X-plane at frame rates maybe above 40 or 50 frames, and your airframe shouldn't be very small or agile because X-plane is not very good at handling very small drones. But anyway, it's an option that you might like to discover in your research or in your project. Awesome. Let's quickly recap what we've accomplished today. First, we set up WSL on your Windows machine. Basically, we created a Linux environment virtually inside our Windows, a full Ubuntu inside our Windows. We then installed all necessary PX4 development tools and cloned the repository of the PX4 and just assumed that we are already in a Linux system. From there, we ran a basic jmavsim demo to ensure everything was working correctly and connected to QGroundControl for mission control and simulation analysis. We also explored how to extract and analyze ULog data, giving you insight into your drone's performance and how it went through all the codes and simulations, seeing different kind of sensors and status and maybe position set points and commands that you sent from your custom code in the virtual world, just like a real world test. Additionally, we set up and ran both Gazebo Classic, which might be nearing the end of its life but it's still useful, and Gazebo Garden, the new modern version of Gazebo. Finally, we introduce you to other community-supported simulators like PX4 Explain, expanding your toolkit for simulating any kind of drone you can imagine in any location in the world with any weather condition or any terrain and other objects inside your environment. So what's next? Imagine having a virtual drone that you can do whatever you like with it. If you are a beginner and you haven't tried real-world drones yet, feel free to use a joystick and experience different flight modes such as position flight mode, altitude, manual, acro, without worrying about any crash or any risk of failure. You can also test different kind of fail-safe modes, scenarios, and operation to understand how each of the parameter and each of the scenario works in real world. If you are more advanced, take it a step further by watching one of my videos on MavSDK or any other Mavlink API such as PyMavLink, maybe Mavros, or use Simulink UAV Toolbox and start implementing your smart custom code to make your drone fly with image processing, real-time decision making, object avoidance, or maybe swarm or cooperative mission, or any other innovation you have in your mind. Okay, that's it. If you found this guide helpful, please give it a thumbs up and hit that subscribe button to stay updated with our latest tutorials. Don't forget to click the bell icon so you never miss an upload. We'd also love to hear your thoughts and experience in the comments below. What challenges have you faced with PX4 SITL, or what bugs you found on PX4 Explain, or what topics would you like us to cover in the next video? Be sure to check out the previous videos linked right here for more in-depth insight into PX4, Mavlink, Simulink, Explain, and all sorts of topics about aerial robotics and smart drones. Links are already on the description below. Follow us on our social media channel for additional tips and updates. Thanks for watching and happy flying and coding.